In section 4.2, we're going to continue to talk about properties of exponents. So in section 4.1, we learned that if we had an exponent of 0, the whole thing became a 1. So for example, this is what we learned in 4.1. If we add something to the 0 power, we just get a 1. The whole thing becomes a 1. We also learned in 4.1 that if you have a negative exponent, the number needs to move, or the variable needs to move, so that the exponent becomes positive. And so this would be like moving it to the bottom, and that 1 would turn positive. So we'd have 1 over 4 to the first power, which is just 1/4. So 0 exponents turn everything to 1, and negative exponents need to move. That's what happened in 4.1. In 4.2, we're going to learn what to do when we multiply powers that have the same base. So if you look in the blue box, it says if you multiply powers with the same base, so for multiplying powers with the same base, we add the exponents. And so in algebra, that looks like if you had a to the mth power and a to the n power, that would be the same as a to the m plus n. And examples down below show you what that would mean if we had numbers plugged in. So for the first example, it said if you have 4 to the third power times 4 to the fifth power, you would literally keep that base the same and add up the exponents. So we'd have 4 to the 8th power. A lot of people want to multiply the 4 times 4 and say it's like 16 to the 8th power, and that would be incorrect. So let me show you why. Let's expand this first one out. If you had 4 to the third power, that would be like 4 times 4 times 4, right? That's what 4 to the third power looks like. But it said also multiply that times 4 to the fifth power. That would be 4 times 4 times 4 times 4 times 4, right? So 4 to the third power is this first one, and 4 to the fifth power would be this second one. And if you count that up, we have 8 4s in a row, right? If you count those up, you have 8 of them. And that's why it makes sense that if you have the same base, you can add up their exponents, because that's what it would look like expanded out. Don't forget it works the same way with variables. And I know some of you were confused in section 4.1 with the variables, but variables are really just numbers eventually, but we don't know what number they're going to be, so we leave them as a variable. So if we say b to the 7th times b to the negative 4th, that b is considered the base, just like in the first example, the 4 was considered the base. In this one, the b is considered the base. Since the base repeats, we have the same base twice, we can add up the exponents. So you would add up the 7 and the negative 4, and you would get b to the third. Before we go to the examples, let me remind you about the difference between base and coefficient. And I know we did this in the last section of notes, but I want to do it again because today it's even more important. All right, so if you have something like 2 to the third power, you have a number being raised to the third power. Then you would call that 2 a base, and you would call the 3 the exponent. That's a little bit different than if you had 2x to the third power. In this case, the 2 is not considered a base. It's considered a coefficient. It is not being raised to the third power. The x is. So the x is what's considered the base, and of course the 3 is still the exponent. All right, so that'll be important for today, that you distinguish between coefficients and bases and exponents. All right, so the steps for today, when we are applying all the properties that we have learned so far, because we've learned 0 property of exponents, we've learned what happens when the exponents are negative, and today we're going to add to it what happens when we multiply bases that have same bases that have exponents. And so first thing you want to do is you can cross off anything to the 0 power. Remember, anything to the 0 power is going to be 1. And everything we're doing today is multiplying. So anytime you multiply by 1, it doesn't change anything. So you can basically ignore it. So that's why we're allowed to do step 1. In step 2, we're going to pull all the coefficients to the front if it helps. And I think it helps. So we're going to pull the coefficients to the front, and then we're going to multiply coefficients. Don't add coefficients, right? The rule we're learning today is we add exponents. We don't add coefficients. Oh, coefficients still get multiplied like they always would. I think it's important to show invisible 1 exponents in our third step, because that way when you're adding up the exponents, you won't forget about the ones that have an invisible 1. And then we're going to combine the same bases by adding their exponents. We'll group them together in today's notes. I think it does help. And then in the very end, we'll move any negative exponents. If they're negative, they can't be in the final answer. So you're going to have to move them like we did in section 4.1. All right, so let's just start with some numbers. In example 1a, we have 12 to the 4th power times 12 to the 3rd power. So we are multiplying like bases, right? The bases are both 12s. So when you're multiplying like bases, you keep the base the same, and you take the 4 and the 3 and you add them up. And so that gives us 12 to the 7th power. Now, I don't expect you to tell me what 12 to the 7th power is. It's some really big number. We're just going to leave it as 12 to the 7th power. In the next one, we have a negative 5 raised to the negative 2 power, and we have negative 5 raised to the 7th power. So again, we have like bases. Our bases are negative 5 in both of these, right? This is a negative 5, this is a negative 5. So we have like bases that we're trying to multiply together. Keep the like base the same. We have negative 5. Add up the exponents. We have a negative 2 plus 7. That's going to give us a negative 5 to the positive 5 as the exponent, because negative 2 plus 7 is positive 5. And I don't expect you to expand it out. I mean, you could take your calculator out and ask what negative 5 to the 5th power is, but we can leave it with the exponent attached to it. Now, don't get confused on this one that we just did. In example 1b, you might say, don't we need to move something? And we do not. We do not have a negative exponent. So you have to remember that the rules we're learning in this chapter apply to our exponents, not to our numbers. So not to our bases, not to our coefficients, okay? So just because we have a negative base doesn't mean we move anything. We would have to have a negative exponent. So that one's actually done. And you could have 3 numbers, right? You're not limited to 2. You could have 20 numbers as long as the bases are the same, which in example 1c, we have the base of 9 3 different times. First it's raised to the negative 3 power, then it's raised to the 2nd power, and then it's raised to the 6th power. So since the base is the same, you're going to leave the base alone. You're going to take the exponents and you're going to add them up. If you take a negative 3 plus 2 and then plus 6, you're going to get a 5. And of course, again, you could take your calculator out and tell me what 9 to the 5th power is, but I don't need you to do that. You could just leave it as 9 to the 5th power. Okay? So that's the new property applied to numbers. If you have the same base that you're trying to multiply, if you have 2 of the same bases, 3 of the same bases that you're trying to multiply, you could just add up their exponents. All right, let's switch over to variables. And again, just remember, variables would be numbers. They would just be some number that we just don't know what their value is yet. So it's going to work the same way the numbers did. In example 2a, we have the same base, right? We have an x and then we have an x again. And so we leave the base alone and we add up the exponents. So we get x to the 2 plus 9, which gives me x to the 11th. Now I should say at this point that this step right here, this middle step here, and then the one I did, I'm going to star all of these. This step that I'm starring is not necessary. I would imagine that when you get good at this, you'd be able to just say it's 4 plus 3, which is 7. You wouldn't need to show me that starred step. You could just go straight to the answer. All right, in example 2b, let's talk about the rules again for a minute. The rules say cross off anything to the 0 power. So it's on the steps on the front of the note. Say step 1 says cross off anything to the 0 power. Well, I don't have anything to the 0 power. Then it says multiply coefficients. Well, the coefficients in this problem are the 5 and the 3, right? They're not bases, they're coefficients. They're not being raised to any power. And so I'm going to pull those to the front. And on the front of the notes, it says if it helps. So I think it helps, especially when we're starting out. So we're going to rewrite this as 5 times 3. And remember, they're showing the multiplication here, this dot, right? This dot right here. Really, everything's being multiplied. It's really 5 times x to the 4th times x to the 9th times 3 times x. They're just not showing all those multiplications, but really that's what's happening in this problem. When things are right next to each other, they're really being multiplied. So if you see a dot, that's one way of showing multiplication, but really there's dots everywhere between all these numbers. So we're going to pull those coefficients to the front. We're going to pull the 5 and the 3 to the front. Then we see that what we have left is x to the 4th, x to the 9th, and just an x. We're supposed to show our invisible 1 exponents, right? So I'm going to put that invisible 1 on that final x. If there's no exponent showing, that means there must be a 1 on it. All right, so let's multiply our 5 times 3. We'll get 15. And then we have x's all in a row that have this, we have the same base, right? The x is the base. So we're going to add the 4 plus the 9 plus the 1. And we're going to get 15x to the 14th power. So multiply your coefficients, but add up the exponents on your like bases. And again, if you don't need to do the steps that I'm starring here, then don't do it. If you can get straight to 15x to the 14th from the original problem, that's great. You can do that. For today's notes, I'm definitely going to make it a few more steps just for the people who need the extra steps. All right, in C, we have a bunch of coefficients. Let's pull those to the front. We also don't have anything to the 0 power, so we're going to pull the coefficients to the front, which are the -4, the 7, and the 2. Then I'm going to I like to just put it in alphabetical order. I have c to the 3rd, I have c to the -2, and then I have d squared. So basically, I rewrote the problem with the coefficients pulled to the front, and then I grouped the same bases together so I could see them all in a row right next to each other. I think it helps. So I've done nothing to this problem but rewrite it at this point. All right, so the coefficients will get multiplied together. So these are our coefficients right here. And so I'm going to multiply those together, and I'm going to get -56. Then I have some bases that have exponents on them, and they're like bases. So I'm going to take my c right at once and add up the 3 and the -2. So I'm going to have 3 plus -2. And then I have d that doesn't have anybody that it needs to be combined with, right? So I'm just going to leave that d squared. All right, so what do we really have? We have -56. C to the first power, right? 3 and a -2 make a +1, so I'm going to leave that invisible, and d squared. So I like to write everything in alphabetical order. I can't remember if the software I'm using does that or not, but I like to do that. But since multiplication's not commutative, or is commutative, we don't really have to write in the order I just did, but you could. All right, but the coefficient should be first. Always write your coefficient first, and then if your variables are not alphabetical, that's okay, but you should put your coefficient first. All right, let's try D. In D, we have j squared times k to the -2 times 12j. The 12 is a coefficient, so pull it to the front. Again, I like to write everything else in alphabetical order, so I have my 2 j's, and I have k to the -2 power. Now, the coefficient's just 12, so there's nothing that needed to be combined there. Let's show our invisible 1 on our j. Anytime it's just a j, right? Even in that original problem, it really meant there was an invisible 1 there. So if we add those two up, we'd have 12j, we'd have 2 plus 1, k to the -2. That would give us 12j to the 3rd, k to the -2. And you might say, well, I combined everything, I should be done. But there's this rule in math that says anything that has a negative exponent should be moved. So we're going to have to create a denominator and leave the 12j to the 3rd at the top. Create a denominator so the k to the -2 can become k to the +2. That's kind of messy. Let me rewrite that because it seems like people maybe wouldn't be able to read that. So I have 12j to the 3rd over k squared. That should be your final answer. So always move negative exponents to make them positive. And again, there's some extra steps here that you maybe wouldn't need. So some people can go, honestly, they can go straight from usually this to this and then switch out all the negative exponents to make them positive. And those middle steps can sometimes be avoided. All right, let's make it a little more complicated and then see how you can do the homework. All right, for this one, wow, it seems like a lot going on. But if you rewrite the problem, don't be scared off by this one, okay? Let's rewrite it by pulling the coefficients to the front. And immediately I see the k to the 0. I'm just going to cross it off. It's going to become 1, right? So I'm not even going to talk about that. It's going to be multiply everything by 1, which doesn't mean anything in math. So we're crossing that guy off, okay? I'm going to pull my coefficients to the front. So I'm going to pull my 3 and my 4 to the front. So that's the 3 and the 4. And sometimes people like to cross off as they go because then they know they have everything. If you want to, you could, I suppose. All right, and then I just like to go in alphabetical order and rewrite it. So I'm going to write, and let's try it. Well, never mind. Let's not. Let's just go in order. So we're going to have H, I see, so H, I, J, K, right? So H is first. H to the negative 4. Keep moving over to the right. So I got that one done. I have another H to the negative 4, so I got that one done. I also have a H to the third power, so I have H to the third power. All right, let's go to the J's next. So I have a J with no exponent on it, so we're going to call that J to the first power. I have another J here to the fourth power, so I have J to the fourth power, and I'm done. And then finally, I have some K's. So the K's, the 1 we crossed off because it was just going to be a 1. It was going to turn to a 1, but we have this K here that has an invisible 1 exponent, and then we have this K here, which is squared. All right, so we've taken care of everything, right? We put the 3 and the 4 at the front in the beginning, and everybody else has been rearranged in alphabetical order. And so if we multiply the 2 in front, we get 3 times 4 is 12. If we add up our h's, we get h to the negative 4 plus another negative 4 is negative 8. Oops, my bad. I forgot about the 3. We got 3 h's in a row, so let's do them all. Negative 4 and negative 4 is negative 8. Negative 8 plus 3 is negative 5. Our J's, we're going to add up our 1 and our 4. That's going to make a 5. Our K, we have K first, K to the second. Let's add those up. We get K to the third. We would be almost done, except for this one right here needs to be moved because it's to the 5th power. So move only that. Leave everything else on top. 12, J to the 5th, K to the 3rd. And move the H to the 5th to the bottom, and when it moves, it becomes positive. And that would be your final answer. Now, if in your final answer on any of these problems, you see a variable more than once, you didn't simplify all the way. You have to combine all of them that can be combined. And so by the end, if you had 2 J's, it means you should have combined them. It means you didn't combine everything all the way. All right, so don't be scared off by something like E. Rewrite it and add up the exponents on the like basis, and then move any negative exponents at the end. Let's try it one more time. So immediately I see p to the 0 power, which I'm crossing off. I don't see anybody else to the 0 power. I'm going to pull those coefficients to the front, which is my 4 and my 2. So I just took care of my 4 and my 2. And then I just, again, like to go alphabetical order. You might, if you don't go in alphabetical order, you won't be wrong. I won't mark it wrong, but I like to just do that. So I'm going to do m to the 4th. I have another m right here, so I'm going to have m to the 1st. Then I'm going to move over to my p's. So I have p to the 4th. And is that all I have? That's all I have. That's the only p I have. All right, and then I have some q's. I have q to the 3rd, q squared, and then q to the negative 2. So I've just rewritten it. I'm going to combine the things that should be combined. So we have 4 times 2 is 8. We have 2 m's in a row, so we're going to write 1 m and add up the exponents. 4 plus 1 is 5. There was only one p, and it was to the 4th power, so we're leaving it. And then we're going to add up all of our q's. A 3 and a 2 add to 5, but a 5 plus a negative 2 adds to a 3. And we are done. So again, don't let a problem like this intimidate you. Rewrite it so that the coefficients are in front. The variables are all right next to each other that are alike, and then add up the exponents on the ones that are alike. If you end up at the end, before you box it, if you end up at the end with something's negative, like we did in E, right here at this step, then you're going to have to move that before you determine your final answer.